ये चैट है जो उधर लिखे आपको उस साइड में सर रेडी योर लाइफ
Hello, can you hear me? This is Professor Balakrishna from IIT Bombay. Can you hear me? Very good afternoon to all of you.
Honey is there. This question is how we talk about honey is there, sir. Honey.
Honey, how are you? Good afternoon. Okay, you have a question. A question about MO diagram for ICL, right? Yeah, MO diagram for ICL is very similar to what we write for F2. In my bonding lecture, one of the bonding lectures, when I am talking about MO diagrams, I have shown for writing a general, okay, I have shown a general MO diagram to write for diatomic halogen molecules. Okay, I have shown F2. Okay, in the same way you can use that one. Okay, what you should do is, for example, F2 is there, here ICL is there. You take one side atomic orbitals of I, one side you take atomic orbitals of chlorine, okay, and both of them have 5 electrons, okay, S2p5 electronic configuration, okay. You put them, only thing is when you are placing them, the energy of atomic orbitals are not equal, okay. Chlorine being more electronegative, you have to put little bit lower, okay, little bit lower in energy compared to iodine atomic orbitals. So best would be, okay, so do that one and then start filling, okay. You can exclude, for example, S electrons of chlorine, you can leave it, then focus on 5 electrons, okay, S2p5, right, 5 electrons from iodine and 5 electrons from you see, okay, frontier orbitals, okay, frontier orbitals means basically highest occupied molecular orbital and lowest occupied molecular orbital are called frontier orbitals. In this case, the frontier orbital HOMO is your pi star, okay, pi star you have 4 electrons, 2px and 2py, you have 2 electrons each, okay, that would be your HOMO. Okay, next one is sigma star, that is, okay, that sigma star is empty, okay, so that is your LUMO, lowest unoccupied, that is it, okay, those are the frontier orbitals. There is no confusion about that, okay. Always you should remember, any molecule you take, when we write MO diagram and we have to define frontier orbitals, highest occupied molecular orbital, and then immediately after that when we have lowest unoccupied molecular orbital, they constitute frontier orbitals. It's very clear, there is no confusion, okay. You take any molecule, for example, if you take transfer metal complexes, okay, many times we have non-bonding electrons, they are in T2G. Oh, okay, that is an interesting question, okay. Yes, if you want to prepare for GATE, well, the 60 lectures can tell you lot about main group chemistry, Wade's rules are there, okay, for boron hydrides, and also I have shown MO diagrams for most of homodiatomic molecule, heterodiatomic molecule, including polyatomic molecules. If you study and solve some problems from Shriver's book and also inorganic chemistry by C.E. Housecraft and A.G. Sharpie, I mean you can get excellent marks in GATE, absolutely no problem. Okay, very sufficient. In fact, I am offering another course, on transition metals. Okay, the course title is Transition Advanced Transition Metal Chemistry. That's going to be started from June, and if you study these two courses, okay, whatever the inorganic chemistry component is there, gate exam, all marks you can get it. Okay, provided you listen to these lectures carefully and try to solve some of the problems related to those things. You should be able to absolutely no problem. It's good enough. Well, how can we prepare main group chemistry for gate exam? Okay, it just you have to read it. Okay, you have to read and also look into the type of questions that originate from main group chemistry. Okay, some reactions, chemically balanced equations and all those things you have to remember, but when you are remembering, it is not mugging or memory based. Okay, the basics have to be understood. For example, if you take any group, okay, in the group what would happen to charge to size ratio, how the first element is different from rest of the element, what happened to basic properties, what happened to acidic properties, what would happen if you keep on adding electrons to the same shell, okay, why size decreases and effective nuclear charge increases. All those things are discussed in each and every group. Okay, if you understand all those things and based on that one, if you read, absolutely this is more than enough. Well, a board and chalk method would be ideal, okay, for teaching, but what happens, I cannot give enough material. That is the reason, okay. If I start writing, for example, a 40 minutes lecture would take, okay, maybe 1.5 hours or 2 hours. As a result, what happens, I will be having some problem in completing because, close it. So always I like teaching with blackboard and chalk, but unfortunately for a course like this, okay, you have seen in all 60 lectures are loaded with lot of information. In order to give this valuable information under one title of main group chemistry, okay, time is not adequate. Probably if it is 60 hours lecture of 1 hour each, then I would have used very generously chalk and board to teach this course. Unfortunately, I cannot do it. But in another course, as I mentioned, I am going to release in June, that is Advanced Transition Chemistry. This is a complete course about coordination chemistry and structure and bonding, detailed crystal field theory, molecular orbital theory, and then 18 electron rule. You will not forget anything. 18 electron rule and metal-metal multiple bonding, quadruple bonding, quintuple bonding. Okay, and also two important reactions we come across in homogeneous catalysis, that is oxidative addition and reactive elimination. Very, very important when we use coordination compounds and organometallic compounds in catalysis. All those things along with reaction mechanism, trans effect, everything is discussed in detail. Okay, and that course and along with this one would be adequate to take up very challenging exam. Jayashri, good morning, good afternoon. Rishikesh, good afternoon. Okay, which chemistry is best for MSc? I mean, which chemistry is best for MSc means it depends. The chemistry you cannot bifurcate. Okay, chemistry is chemistry. Chemistry has physical chemistry component, inorganic and organic, and even biochemistry is there, and everything together will constitute chemistry. And in that context, I would not say which chemistry is good. The chemistry as such is wonderful. Okay, you have to focus on all aspects. And physical chemistry is more problem oriented. Okay, if you solve more and more problems, understanding physical chemistry concept would be very easy. And same thing is true in case of inorganic chemistry also. Spectroscopy is there. Okay, and bonding is there. And when you put everything together, you put organic chemistry, physical chemistry together, inorganic chemistry comes. Okay, so in this context, if you ask me which chemistry is best, general chemistry is best. It includes everything. In fact, inorganic chemistry itself is general chemistry because it has all component and it deals with all elements, 118 elements. Okay, it deals with. So inorganic chemistry is considered general chemistry. Organic chemistry is a branch of inorganic chemistry, I would say. Okay. Okay, if you want to, contact me for anything, you can always, write to me by email. My email address is there. You can note it down. Krishna. Yeah, okay. Right. Krishna @chem.iitb.ac.in. If you have any doubts, you can always ask me questions. I may not be able to write to you immediately because I am busy with so many things and lot of things will be there, but certainly I shall try to answer your questions. Okay. Rishikesh, how are you? Hope you have understood my explanation about which chemistry is best for MSc, right? Okay, so remember this email, okay? Oh, another person asked me a question about Capelt model, right? He's there. What is his name? Sadiq.
Muhammad Sadiq.
Sadiq, are you there? Yes, yes, honey. Okay, I told you one more inorganic chemistry course is coming. It's very good course. I'm telling you. It has lot of information, ideally suited for you to take up any entrance exam. Okay, and to get good grades, whether it's CSIR, GATE, and all those things. Of course, the basics you have to understand very clearly. I have given stress for basics in those courses. Okay, I'm sure I would come up with more courses on inorganic chemistry topics. Okay. Any more queries? Can you hear me? Rishikesh, Honey, Jayashree, can you hear me? Okay, main group chemistry has any scope on forensic chemistry? You see, forensic chemistry means, okay, that by definition you know for what it is. Okay, of course, the entire chemistry is needed, okay, especially when you talk about forensic chemistry, this many of these elements are the, will be there in whatever the forensic chemistry related stuff. If you go, main group chemistry is inseparable. Okay, main group chemistry is very much it is there in it. Okay, forensic chemistry has the entire chemistry is there. Whether it's transfer metals are there, whether it's S block elements or P block elements, to an extent even alkyl, even lanthanides and actinides are also there. Yes, all these. Okay, the entire chemistry is there in forensic chemistry. We have some limitations. Unfortunately, I cannot increase the number of questions in assignment. Okay, so based on what you should do is, every time when you look into, okay, a textbook, or when you read, or when you listen to my talk, okay, you try to generate yourself question. For example, you take any textbook and read one page, try to generate at least 2 questions from it, okay, and then try to answer, okay. In that way, what happens, you will be learning and understanding, and that remains, okay, forever in your mind, okay. And we have limitations. That's the reason we cannot go beyond 10 questions, okay. Nikhil, how to study basic chemistry? Well, yeah, basic chemistry, how to study means, if you go through my course, okay, I'm giving emphasis for basic chemistry here, okay. Basic chemistry means when you go for S and P block chemistry, when you say basic chemistry, it's about understanding periodic trends and periodic properties, okay, size to charge ratio, effective nuclear charge, and electronic configuration, what would happen to ionic radius, okay, and what would happen to atomic radius, okay, across the period down a group. These are all basic chemistry, okay. And what would happen to the properties, okay. For example, if I make nitrogen to hydrogen bond, similarly I should be able to make phosphorus to hydrogen bond, and similarly arsenic, antimony, bismuth also I can make. Then what would happen to stability, what would happen to reactivity, and how stable. So these things would be better understood if we understand the basics, okay. And why acidic properties decreases or basic properties increases, all are there, all ingredients are there in the basics. That's the reason you have to read textbooks, because if you read some questions and answers, any guide or anything, it's of less usefulness for you. It deals with only that particular question. But when you look into the textbook gives importance for basics, okay. From that point of view, always try to read basics and then try to answer the questions with your knowledge, okay, with your basic knowledge, okay, then that should help you, okay. Okay, you want to know, honey, you want to know about my research work, okay, good. Okay, I'm an inorganic chemist, okay, and in our group what we do is we make lot of ligands. Of course, ligands are very important component of coordination chemistry and organometallic chemistry. We design new type of ligands, especially phosphorus based ligands. We call them phosphines, right? Tertiary phosphines. In that one, tertiary phosphines, you can have simple monophosphines, bisphosphines, trisphosphine, tetraphosphines, and all those things. Why do we make? They are very good ligands. Why they are very good ligands? Because they are sigma donors and pi acceptors. And again, in order to understand the type of ligands we have to go with the classification of ligands by donor atoms. Again, this entire topic I have described well in detail in my next course that is going to come. Okay, I try to make you familiar with every type of ligands that you come across in coordination chemistry. So we make these phosphines and then make coordination compounds and organometallic compounds, and after making those things and understanding their reactivity and properties, we try to use them in catalytic applications, homogeneous catalysis, and also if the compounds are good and less toxic, we also try them in anti-tumor studies. Okay. So, well, you are talking about astatine. You say astatine is yeah. So okay, you're talking about astatine, right? Astatine would be, it's a its properties, if you look into it, it should be more basic, okay. Astatine will be below iodine, it's radioactive, right? If it is radioactive and its behavior is very similar to metal, okay. little bit metallic property. I would say it is not, you can see not much information is available about those things, okay. There are radioactive materials with very short half-life, okay. And if you just look into like tellurium and iodine, whatever you call, similar behavior is anticipated with less reactivity, okay, compared to iodine. Yeah, what is about doubt about Airbag concept? Okay, electron neutrality principle. Again, electron neutrality principle is more applicable for explaining bonding in coordination compounds. Okay, so electron neutrality principle and Keppelt model were initial attempts by chemists to explain bonding in coordination compounds. What happened? By the time valence bond theory came and it was well established to explain bonding in main group chemistry, S and P block chemistry, using Linus Pauling's hybridization concept. So they started, some way of explaining bonding in coordination compounds. And coordination compounds explanation is not easy. Okay. For example, if you take metals D1 to D10, all of them can form hexa-aqua compounds, but have different number of electrons in d orbital, D1 to D10. So in that case, what happens, whether you have to consider d electrons or not for bonding, and all these things were there. Of course, once crystal field theory came, everything got cleared, all doubts cleared, and now we have ligand field theory. Ligand field theory is as good as molecular orbital theory, and that can explain literally everything about metal complexes and their applications, and why they are good for catalysis, why they are good in materials, why they are good in some other applications. Everything can be explained using crystal field theory, including their spectroscopic properties. Okay, and this electron neutrality principle is one in which the assumption was that any metal ion, okay, or a species, okay, should have a charge within plus or minus 1. That so, and best ideal would be 0. That is the electron neutrality principle. That means a species would have, okay, charge plus or minus 1, okay, upper limit plus 1, lower limit minus 1, and ideally 0. That means that was the electron neutrality principle, and whenever they made a complex, they try to distribute the charge on ligands and metal in such a way that they have less than or equal to 1 or close to 0. That is called electron neutrality principle. Okay, so that also I am discussing in my new course. Well, yeah, organometallic chemistry, yes, organometallic chemistry also can have separate mechanism and all those things, but as I mentioned, my course is sort of hybrid between inorganic in coordination compounds and organometallic compounds. Probably best of organometallic chemistry I have taken, and I have not excluded anything from coordination chemistry. Okay, and alkyl migration, all those things are very special cases. Okay, and in this course I have not covered that one, but nevertheless, maybe in the next year I shall try to offer one more course on organometallic chemistry. Okay, I take your suggestion, honey. Okay, in that one, how they are kept together. Okay, basically what happens, nothing is kept there. Okay, so we have taken azide. Okay, sodium azide is kept. Sodium azide is kept in a very small, bag type thing, and that is connected with the electronic device. Okay, electronic device is connected, and then you have already, I have given explanation everything. Okay, when the little impact is there, when the impact is little bit more than what we see when we hit the hump or something. So when we are driving, suddenly if you don't apply brake with 40 km or 50 km speed, if you move hump, okay, then your vehicle get a jerk. Okay, for such jerk, what happens, your airbag should not be get alerted. Okay, it should really go for impact. The moment impact, we have some scale for that impact. When that impact is more than that, that means when really hard hit the front portion or something, then when that triggers, the electric spark comes and immediately a sodium azide getting ignited. Okay, and then N2 comes out. When the N2 comes out, that is responsible for expansion of the bag like compressed air. Okay, I told you a typical airbag would have about 60 grams of sodium azide, and also we have put, the moment azide comes out, we have also put other components in another bag. Usually they also open up, and then the neutralization happens in that one. Okay, so I have written the balanced chemical equation. Okay, just look into it. Okay. Is that clear, Jayashree? Okay, keeping them without mixing, it should be a problem. Okay, it should be a problem. Okay. Hi Selvam, good afternoon. So Jayashree, what you are studying now? Honey, what you are studying? Well, I don't know. I don't look into, I don't look into question and answer books for anything. Okay, so I do not have any idea about the kind of books one should look for GATE exam and all those things. Okay, I can tell you good books, but I do not know, and I don't want to use any, question bank. Okay, for practice, yeah, for practicing inorganic chemistry, as I mentioned, C. Housecraft and A.G. Sharpie book is very good, and and then inorganic chemistry by Shriver and Atkins is another book. So just go back to the exercise and try to solve all the problems. That is more than adequate. Okay, and then you see, once your basics are clear, whatever the question that is given, you should be able to extrapolate from your basic knowledge. Okay, you should learn those skills. I can tell you one example. You just look into the molecule PPH 4 times I7. Okay, PPH 4 times I7. Okay, and for example, if a question is asked about that one, PPH 4 I7, I7 is the counter anion, PPH 4 in square bracket, outside I7, iodine 7, iodine subscript 7. Okay, so in that one, for example, if the question is asked how this compound can be prepared, immediately you will give up thinking that you do not know anything about that one. But on the other hand, you can answer that question. Okay, how to answer that question? Okay, yes, what is the central atom there? Okay, phosphorus first. Very good. Okay, phosphorus is there. Phosphorus belongs to which group? Group 15. Group 15 we call them as nitrogens. Okay, nitrogen, phosphorus, arsenic, antimony, bismuth. Okay, so now, okay, phosphorus has 4 bonds surrounding it. 4 phenyl groups are there, and outside I7 is there. Okay, okay, let me go back to nitrogen to see whether similar compound is there or not. Yes, nitrogen, what is the simplest compound I know? NH3. Fine, NH3 is there, and if NH3 is there, and if NH3 experiment you have done, you take an ammonia gas and expose to HCl gas. Okay, take ammonia, liquid ammonia, and dip a glass rod in HCl and hold it, you get white substance. That is ammonium chloride, NH4Cl. So NH3 was there and HCl, NH4Cl it became. So NH4 plus and Cl minus. Oh, okay, I know about this one. And okay, now PPH4 I7 must be similar to that one. PPH4, that means NH3. Okay, PPH3, triphenyl phosphine, I know. Okay, one more phenyl group is there. Okay, one more phenyl group is there. That means HCl, in case of Na3HCl, okay, then pH is there, Cl not pH, iodobenzene. Okay, I know now, triphenyl phosphine plus iodobenzene. Now I7, okay, here I get only I, another 6I, where it comes? Okay, I have done iodometric titration. There, I2, okay, I minus is, you cannot distinguish readily. So what you do is you add iodine to it, so it forms I3 minus. Okay, if I add 2 iodine, it may become I5 minus. If I add 3 iodine, it becomes I7 minus. Oh, fine, I got it now. Okay, I can write the equation to form this compound. Okay, triphenyl phosphine plus iodobenzene plus 3I2, it will give you that compound. Okay, so this is the called analytical thinking. And if you do that, any exam comes in GATE, CSR, anywhere, even JE advanced, you should be able to answer. You got my point? You got my point, honey? Jayashree? Is it not simple? Selvan, so you have any question? Who is my favorite Iranian chemist? Who is quinoline? Very interesting name. What is your correct name? Quinoline? You see, all, okay. Was that explanation was useful for you? How to make PPH4I7? Looks very complicated molecule. Now it looks very easy, right? So I will write it again, the same equation for you. This one, for PPT. How to upload the research paper? Okay. Oh, is it quinoline is Priya? Nice name. Here? Okay. Let me write it again. Okay, for example, pen. Getting something? Okay. ये लिख सकता हूँ ऐसा नहीं lose content. I'm not visible, they say.
It's not visible. So you can write.
Huh?
You can write.
I'm not visible.
You can write.
No, it doesn't matter. You can see me. So, whatever the, reaction I explained, okay, let me write it again. For example, something like this is given, okay, give the preparation of this compound, okay, then certainly what happens if the first question is this one, you will panic, you will be scared of going for next question because you think you cannot solve this problem. That is where the problem is, okay. Whenever you go for writing any exam, okay, you have to be confident, and of course for that one you should have studied well, okay, and then you should not get panic, cool, okay, then try to understand the question, okay, try to simplify it, nobody can walk straight away, okay, the baby born will crawl first and then try to stand up, then walk, then learn bicycle, then car, then helicopter, then plane, like that, okay. The first day itself you cannot do everything. That means we have learned already starting from 9th grade, okay. Only thing is you have to put that into critical evaluation in your mind. How to do that one? You have to have analytical thinking, okay. You should not think only in one direction when you want to solve a problem, okay. For example, as I said, this one, okay, this is group 15 element. Group 15 we have nitrogen, phosphorus, arsenic, antimony, bismuth, okay. All of them have S2 P3 electronic configuration, all of them have, okay. This may be 2s2, 3s2, 4s2, 5s2, 6s2, it goes like that. 5 electrons are there, all of them have, okay, 3 and 5 stable oxistates, okay. So something like this you should be able to tell, okay. You should be able to. Then let us come to this one, okay. I do not know at all, okay, but I know something from N. What is the simplest chemistry I know? NH3, okay, fine, NH3 is there, and then iodine is there. Iodine I do not know, okay, fine. Chlorine I know, okay, and then chlorine, and then here 4 are there, okay, 4 are, okay, yeah, okay, so this is not correct, okay, so this is, yeah, correct, I think, PPH3, okay, PP, okay, so this is sorry, this is incorrect. What I wrote is incorrect. PH 4 times I7, okay, that was wrong, okay, this is the one, PPH 4 I7, okay. Give the preparation now, okay. PPH 4 is there, okay. Now if PPH 4, the simplest form will be, okay, if you go back to replace this RL group with hydrogen, then it will be PH4, okay. PH4 I do not know, but I know NH4, okay. NH4 I do not know about I, but I know about Cl, okay. How it has come? NH3 plus HCl, okay. This is called quaternization, okay, ammonium salt. So that way it is a phosphonium salt. This one is a phosphonium salt, Okay, how this is made? This is made from NH3 and HCl in 1:1 ratio. Oh, I got it now. Okay, this I know. Triphenyl phosphine I know. Okay, triphenyl phosphine is there. Okay, then one pH means, okay, pH and iodobenzene. So this is nothing but iodobenzene. Okay, fine. Then I2. This I7, what is this I7? I is there, another 6I where it comes. Okay, I is there. You are familiar with I3 minus, I3 plus, all those things when you learned VSCPR theory, valence and electron pair repulsion theory. You have already studied about I3 minus, I3 plus molecules. Okay, if I3 plus can be there, I3 minus can be there, I5 minus can also be there, and also I7 minus can also be there. Why not? So this is how you should start predicting. Okay, you should start predicting. Then how I3 minus is made? I minus plus I2 gives I3 minus. Oh, okay. What would happen if I add 2I2? It becomes I5 minus. What would happen if I add I minus plus 3I2? Oh, I got it. It gives I7 minus. Okay, I know now. Okay, for this one, 3I2. Okay, so this should give your compound PPH 4 times I7. Okay, right? So if you start thinking in this direction, okay, you can solve any question no matter how complicated it looks like. Tomorrow it may not be there. In this place maybe this one may be there. Okay. Okay, this also same. Okay, or we have something like this, or even SB, okay, some AR, a bigger group, okay, AR5, okay, AR is defined something, AR equals, they say something like this. Okay, this is here, so this is something like this is there, doesn't matter. Okay, so then, okay, you take SBR3, we can take SB AR3 and take AR iodine plus 3I2. You got it, right? So this is how you should work on it. Okay. Okay, is that clear? Okay, now you please ask any questions that are related to this course itself now. Okay. So what happens, let me not go beyond the scope of this course. Let me, okay, please, okay. So now try to develop this kind of, problem solving mindset. Okay, and then tomorrow if you become teacher, you have to teach in this way. So then how to go back? Okay. Can you see me now? Okay, now you see I just showed you this reaction. Of course, all these reactions have to be carried out in non-aqueous medium in any organic, okay, solvent, in an organic solvent, maybe organic polar solvent. Okay, simply if you put it, it forms. Okay, even you can form this one at room temperature. Okay, just I showed it as an example. Okay. So you are preparing for GATE exam, honey, do well. Selvan, you didn't ask any question. You have any question, Jayashree? Apart from car bag? So all the best to you, all the best to all of you. Okay, and I am sure all your dreams will come true. Okay, be sincere in whatever you do. Okay, and I wish you all the best. No, N3 minus, okay, yes, azide is there, pentazole is known, N5 minus is also known, okay, N7, yes, it is difficult, okay, I have put a slide about that one in my course, okay, pentazole that is called, it has cyclic structure, okay, but they are all, very explosive materials. Well, I do not know how to guide you, okay? Basically, you have to be thorough with the subject, then you should be able to answer, okay? Guiding means I can always say that you do well, you study, that is it, okay? Try to understand weights rules. Weights rules are very, very important, okay? And it's very simple, weights rule, okay? And you have to learn how to count valence electrons. If you take, for example, simple, I will tell you how to use Wade's rule for understanding P4 structure. P4, okay? P4 if you take, okay, let us say white phosphorus has tetrahedral geometry, okay, tetrahedral geometry, and is it possible to derive using Wade's rule? Okay, Wade's rule, what it says, if n plus 1 skeletal electron pairs are there, if n number of vertices are there, okay, then it would be closed. Okay, if n minus 1 is there, okay, if n plus 1, n minus 1 is nido, n minus 2 arachno, and if you consider here P4, okay, P4 if you consider, what would happen is three electrons are there, okay, 3 electrons means, okay, 3 into 4, 6, 12 electrons are there, 12 electrons means 6 pair. If the 6 pair is n plus 1, n is 5, okay, n is 5, okay, if n is 5, what would happen? It should be pentagonal bipyramidal, okay, so that is closo, okay, but you don't have 5 atoms, you have 4 atoms, then it should be nido. Nido means basically from trigonal prism, trigonal bipyramid, you take one vertex, one vertex out, okay, then it becomes tetrahedron, okay, you can arrive at white phosphorus geometry simply by looking into Wade's rule, okay, so if you study like this, okay, you should be able to answer any question. This is how you should prepare for GATE exam or any exam for that matter. So there are two types of N3 minus. One is N subscript minus, okay, that is azide. The other one is N3 minus is nitride, okay, that we use in coordination chemistry, okay. N 3 negative charges is nitride. N3 3 nitrogen atoms with 1 negative charge is azide, okay, Rn3 sodium azide, okay. So you should know the difference between N3 minus and N3 minus, okay. Any other questions from anyone else? So research papers are usually comes in journals. Okay, we call inorganic chemistry journal, organic chemistry journal, all those things. Okay, it comes there. Okay. So you have to look for it. Okay, I will send you a couple of research papers. You just write to me. I will send you a couple of research papers so that you can read it. Okay. Azide is N3, okay, 3 nitrogen atoms and 1 negative charge, that is azide, yes. Yeah, many organic azides are there, okay, quite stable, okay, although they are explosive, if we know how to handle them, okay, we should be able to make them and we can even distill and purify them, there shouldn't be any problem. Okay then, if there are no questions, okay, maybe see you in next session. So have good time. Okay, read and read, okay. That's the only way to learn things. Even I read a lot, even now. Okay, even I feel that I haven't learned much in chemistry. Okay, it's never ending. Okay, if there are no more questions, okay, I shall stop it. Okay, maybe see you all in my next live session. Until then, okay, have a good time, take care. Yeah, bye. Mm-hmm.